All right, so this is the Thursday notes practice or review, which means it reviewed all three of these formulas. So let's start with number one. First thing we need to do is figure out, as soon as it says S, it means I want the sum. I want the sum of the first 25 numbers. So what you have to do is you have to figure out first, is it an arithmetic sequence or is it a geometric? And when you look at it, it's kind of like -1, comma 2, comma -4, comma 8, comma -16. So if I look, and I look here, it looks like it's being multiplied by -2. Since it's being multiplied, it's a geometric sequence and it has a limit. So since it's a geometric sequence, I'm going to use one of these. I use this one because it has a limit. So I'm going to write the generic formula right here. You can see how I remember things. You could put the a sub 1 on top. It's the exact same thing. Okay. So what I'm going to do is I'm going to plug in the first term. That's what goes in there. The ratio is -2. Oops, I put r minus r instead of 1 minus r. Okay, and I could have just done a big parentheses. It was just a habit. And then the n is 25. So now I'm going to go s sub 25 equals a sub 1 times 1 minus the ratio, oopsies, to the 25th power. Now notice, I can't make those two negatives positive because I'm taking -2 to the 25th power over 1 minus -2. Okay, so I'm actually going to be too lazy to plug all of this into my calculator. 1 minus -2 is 3. And so it's actually going to be -1 times 1 minus, keep it like that. This is what I'm going to plug into my calculator, over 3. Okay, so you don't need to write that down, but I just want you to see kind of what I'm doing. Okay, so I'll erase that. But just understand why I'm doing that. So I go control divide to get a fraction, -1 parentheses, 1 minus parentheses, -2, don't put -2, it'll confuse it, to the 25th power. And then over 3. Okay, so the sum of the first 25 numbers is -1, 2, 3, 8, 4, 8, 1. Okay, that's the sum of the first 25 numbers, and that's it. Let's go to the next one. The next one, I want the sum of the first 9 numbers. I need to decide, is it arithmetic or geometric? I see that it's adding 8, so it's a difference. Therefore, if it's arithmetic, I'm going to go back and use the formula for the arithmetic sequence, where this represents the first term and the last term. So I'm going to write down that formula. The more times I write it down, I know it starts with n over 2. First guy plus last guy. Okay? So I'm going to find the sum of the first 9 numbers. The number that I'm focused on is my n. Okay? So that would be 9, and that's 2. My first term is 72. Now, the most difficult part is figuring out what goes here. So then that means what I have to do is I have to figure out what would be my 9th term. So I'm going to have to go down here, a sub n equals a sub 1, n minus 1 times d, because I'm using an arithmetic sequence. So I'm really going to find the 9th term in the pattern. So I use the first term, 9th term in the pattern, and the pattern's 8. 9 minus 1 is 8. 64 plus 72 is 136. So that 136 is what's going to go in here. And now I can just pick up my calculator, type it in as it is, turn it on, control divide. Where are we? 9. The 2's on the bottom. I don't know why I did that. Made that more difficult. Oopsies. Parentheses 72 plus 136. Press enter and I got 936. So that means the sum of the first 9 numbers is 936. Okay, let's go to the next one. I want the sum of the first 9 numbers. Okay, I have to look, see if it's arithmetic or geometric. I can tell it's geometric. So we know that it's a ratio. We know it's positive, and we know it's getting smaller and smaller, so we know it's a fraction. So here's the truth. You know that it's either this divided by this or this divided by this. So let's try doing 2,500 divided by 1,500. The problem is that's 5/3. That's bigger than 1, which means the numbers would be getting bigger and bigger, and that doesn't make sense. because that would be me going 2,500 times control divide 5/3, and I should get the next number, but that's 1,500, and that's not that, so that doesn't work. So I go 1,500 divided by 2,500, which is 3/5. How you know I'm right is if I go 2,500 times control divide 3/5, boom, I get the next number, which is 1,500. Okay, so I have my ratio. I'm going to use the exact same formula that I did here. A sub 1, 1 minus r to the n, a sub 1, 1 minus r. Okay, I'm going to plug it in. So my first term goes there. My ratio goes here. And then the number that I want is 9, so that's going to go in for my n. And right there as well. So I'm going to go s sub 9 equals 2,500, 1 minus my ratio to the 9th power over 1 minus 3/5. Okay, so I could definitely plug all of that into my calculator, and some of us just kind of feel like there is so much happening, it might just be easier to do that. Some of you might want to go 1 minus 3/5 is 2/5. 2/5 is the same thing as multiplying by the reciprocal, which is 5/2. And then you go to 1250, you multiply that out, okay? Whatever you want, I don't care. But the most simplistic thing to do to me is just copy it as it is. Control divide, 3/5. I want to make sure that part is in parentheses. This is a lot of parentheses. To the 9th power. 1 minus, and I would probably do 2/5, but I just want to show you that no matter what, you can just get the answer. And I get a crazy fraction, but it works. So the sum of the first 9 numbers is, that's straight as it is, 3,866,884 over 625. Okay, let's go to the next one. I need to find the sum of this sequence. I need to decide if it's arithmetic or geometric. I notice this is times 2 and this is times 5, so it's a ratio of 2/5. But how this differs from this one is this one tells you the sum of the first 9 numbers. This says, okay, the sum of the infinite numbers. So that means that I'm not going to use this formula now. I'm going to use a simplified version. If you look, it's just that. Okay, so I'm going to write that down. S sub n equals a sub 1 over 1 minus r. And I actually memorized this one. And then by memorizing this one, I know I just put that on top. It's easier for me. Okay. All right. So the sum of the infinite numbers equals the first guy over the ratio. Show my work. 2/5, 1 minus 2/5. Some of you know 1 minus 2/5 is 3/5. If you're multiplying by the reciprocal, it's multiplying by 5/3, which is 2/3. Others of you will just take this whole thing, which is fine, and plug that into the calculator and get 2/3. Make sure you write infinite. Now I want to show you something. If this was 2/5, let's say this time the ratio was 5/2. If the ratio is 5/2, that means the ratio is greater than 1. There is no sum. It is divergent. Okay, or you can just say diverge. It will diverge. It will not end. Okay, this one would be considered converged because the ratio is less than 1. Okay, that's your practice from the day before.